In this video, we're going to start talking about flexibility. And we talked about why flexibility is important from a warm-up standpoint and how that's one of our main goals of designing a good warm-up. But now we need to get into the science and how flexibility works and what we're actually changing when we do our warm-up. Now, we have active and passive range of motion, or active and passive flexibility. And we said in class that active range of motion was where, if we're looking at my shoulder, the muscles around the arm are actually going to contract or activate, that's where it gets its name from, to move my arm. So for example, my arm is now contracting, these muscles are working hard to lift my arm up, and at a certain point I can't go any further. That would be my active range of motion. I can go from here to here by activating those muscles. Passive range of motion, on the other hand, is where my arm is totally relaxed and I have a friend or a partner or an implement lifting my arm for me and moving it for me, right? So the muscles themselves are totally relaxed and they're just being moved by something or someone else. Now, what we know is we know that passive range of motion is going to be greater than your active range of motion. And this should be intuitive, right? Because if your arm is totally relaxed, it's easier to move it through a full range of motion than when you're actually contracting. Now, one of the reasons why it's easier or why you have greater passive range of motion is because passive range of motion is only really going to be restricted by a few things. If the bone structure is set up in a way where bone is hitting bone, that's where you're going to stop. So as I lift my arm up for me, at a certain point, my bones are going to start knocking into each other and they can't go any further. In the same way, we have connective tissues, and those may be restricting it. So as I'm going up, at a certain point, I run out of space, it starts stretching something that doesn't want to be stretched, it's going to restrict me. Or perhaps I have an injury. So maybe I have bone spurs that affect that joint. Or maybe I have some scar tissue from a previous injury and that's going to restrict my range of motion. So passive range of motion is going to be limited by, think, structural deficiencies or structural problems, right? Bone on bone contact. Active range of motion, though, we don't even get to the bone on bone contact before it stops. So as I'm lifting my arm up, I probably won't get that bone on bone contact. And one of the reasons, or one of the things that restricts your active range of motion, is going to be the muscle itself. So how activated are those muscles? If they're overactivated, that can actually limit or restrict range of motion. And we'll explain that concept here in a second. Now, when we're talking activation, we have to remember that our muscles don't just spontaneously contract, right? They don't just decide to contract on their own. They have to receive a signal from your brain or your nervous system. And so things like stress and things that will affect your nervous system will actually change your active range of motion. Now, if we're thinking about changing range of motion through a warm-up, it's going to be really difficult to change the structures of your joints, right? Technically we could do it, so we could put you under, we could give you surgery, and we could go in there and we could actually shave off some of that bone, or we could shave off some of those bone spurs to increase your passive range of motion. But it's not really something we would do on a daily basis, changing the structures underneath someone's body so that they could increase their range of motion, right? That would be pretty extreme. So realistically with our warm-up, we're really not doing a lot about this passive range of motion. However, we can do much or a lot to increase our active range of motion, right? And so what we can do is we can target the muscles themselves and how they are structured and how they function, or we can target your nervous system and how it sends signals to those muscles. And that's relatively easy to change, and you can actually do that pretty quickly. Now let's talk about how we can change our active range of motion. And the first thing we need to do before we can get into the specifics is we need to have you understand a key concept. And what that concept is that even sitting here totally relaxed right now, at rest, my muscles aren't totally deactivated. They're not at 0% activation. There's a small muscular contraction happening at any given second. If you were totally relaxed, or I gave you a muscle relaxant, you would just be hanging here dangling, kind of like a puppet. That's what it would look like, right? You would have nothing going on. But even sitting up here maintaining a basic posture, we're gonna have to have our muscles activating a little bit. And what we call this is, we call this muscle tone. And we're talking about the tone, or how activated that muscle is. So let's say right now, if we're looking at my biceps, let's say it's activated 5%. And just to keep things simple, let's say that I could lift 100 pounds, so 5% would mean it's pulling about 5 pounds worth of weight. Well, if we're thinking about this, if my biceps is contracting at 5 pounds, why isn't my arm moving? Well, if we remember, and I said your muscles are all going to be activated at some level or another, if my biceps is contracting 5 pounds, my triceps, which is on the opposite side, or the agonist-antagonist relationship, if you remember that, biceps is the agonist, triceps is the antagonist, they pull the arm in opposite directions. If this one's pulling 5% and this one's pulling 5%, my arm's not going to move. It's going to stay locked in its position because they're pulling opposite, kind of like a tug of war, right? They're pulling the exact same amount, so there's no movement happening. So at rest, if we increased your muscle tone or the activation level, so let's say instead of it being at 5%, now it was at 20 or 30%, and we did it the same on the opposite side to 20 or 30%. It would be much harder for that muscle, for that joint to move, and you would see that it would restrict your range of motion. So I want you to try an experiment right now. I want you to stand up and I want you to find a wall, and I want you to reach out so that you can barely touch that wall. Now, what you're going to do is you're going to take your hand, you're going to bring it in, and you're going to contract your entire arm, make a fist, and clench your teeth. And you're going to do this for 10 seconds. 10, 9, 8, 7, 6, and your arm should be shaking because you're contracting so hard. 3, 2, 1. Relax, and then reach up. And you'll notice that your hand or your arm might not be able to reach the wall anymore. And if you did this experiment correctly, what you would have done and what would cause that difference in length and the reason why you can't reach it anymore is because you've actually changed the muscle tone in those muscles. Because they were contracting, you increase the activation or that muscle tone. And that's going to be a key concept when we're talking about increasing our range of motion. We're going to be talking about how we can change the muscle tone. But this kind of begs the question, how does our body know what muscle tone we need in a given second? How does it know to have it at 5% and not 30%? Right? And we said it's coming from the brain. The brain is telling it to maintain a level, but where's the brain getting its information? Well, in your body, you have a variety of different receptors. And all receptors is they're just these cells in your body that are giving specific types of information and sending it to the brain. And you have a specific type of receptors called proprioceptors. And what proprioceptors will do is they will give your body information about your joints and your muscles and how they're working and where they're at in space. And so when your body is trying to determine how much muscle tone it needs in a given second, or how much muscle activation is required for a given task or a series, it's going to rely on your proprioceptors. And there are 4 proprioceptors we're going to be talking about because they directly influence your muscle tone.